All right, guys, this is Unit 5 Progress Check Multiple Choice with a little bit of FRQ stuff at the end. We're going to start off at 9 because we got up through 8 in class today. Question 9 is asking us to find intervals of increase and decrease for a function, and we're not supposed to use a calculator. So the way that you find an interval of increase or decrease is you start by finding f prime. F prime is the slope, and slope tells you where a function is increasing or decreasing. Next, we're going to set it equal to 0. The next thing, I need to get rid of this x. The x won't be here anymore after we do the derivative. The next thing we do is divide everything by 6 because that can be reduced. So I'm just going to divide everything by 6. And then we go ahead and factor. Set this piece equal to 0 and you get -4. Set this piece equal to 0 and you get 1. And then from there you're going to do your number line test. So we're going to pick a number to the left of -4 and plug it into our first derivative to find out whether our function is increasing or decreasing on that interval. We'll pick a number between -4 and 1, and then a number past 1. And we'll see what we get. So if I were to plug in 2 into my first derivative, I would end up with a positive outcome. Now I'm not going to calculate it. I just did it mentally by looking at the equation, but you'll come out with a positive. If you plug in 0, you get a negative. If you plug in -3, you're going to get a positive also. And so we could see that we are increasing on the intervals from -infinity up to -4, as well as 1 to infinity. And we're decreasing on the interval from -4 to 1 because that's the interval where the first derivative is negative. All right, let's move along here to question 11. It's actually pretty much the same thing. We're still going to do a number line test, but they just want to know where we have a relative max. So you are going to make this thing equal 0. You're going to set each piece equal to 0 and solve, and you end up with these. Do a number line test once again, smallest to largest, and plug in some numbers to see if you end up with a positive or a negative. So I'm going to plug in some numbers here. For each interval. All right. If I were to plug in -5, I would get negative, positive, negative. So that's going to end up being a positive on this interval. Here, if I plug in a -1, I get negative, positive, positive. That's going to be negative. And this will also be positive here. All right. So we want to know, where do we have a relative max? Well, let's sketch some slopes. So for the first interval, it's going upwards because it's a positive slope, then down, then up, and then up some more. So this is the relative max here at 4. So that's how you can find relative extrema. It's called the first derivative test. All right, question 12. We're going to be given a graph of f prime. They want us to find the relative extrema. So where the graph of f prime goes from below to above the x-axis, like that, that would be a relative min. And whenever f prime goes from above to below, like that, then you have a relative max. Okay, so I'll let you guys use that to answer question 12. Let's move into the FRQ portion here. All right, guys, going to take a look at FRQA number 1. Part A says, what open intervals contained in -1 to 3 on the graph of f is concave up? So f is concave up when f double prime is greater than 0. Now, since they've given me the equation of f double prime, I just need to find out where that graph is above the x-axis. And anytime this is above the x-axis, that means it's greater than 0, which means that f is concave up. So let's go ahead and go to our graphing calculators here. And we'll type in the equation. Then we'll push graph. And we don't like that window. We want to see from -1 to 3. And that way you can have a little bit more of a reasonable looking graph. Now I'm noticing like right about here and here, it's a little bit above and below, but it's just kind of hard to tell where. So I think I'm going to try to zoom in a little bit. I might want my graph only to go from like maybe here to here, so like maybe like +4 to -4 for the y-axis. Maybe get a little bit better looking of a picture. So it doesn't look to me like it's going above the x-axis here at all. So I don't think that it does. And we want to know where it's concave up. So really all I care about is this interval here where it's above the x-axis, and here also. So let's go ahead and find where that is. So I'm going to go ahead and graph the line y equals 0 now. And I'm going to find where this graph intersects 0. So there's one answer. It's 1.253. And we'll find the other one. There's another one, 2.170. And we have one more to find over there. And that's 2.802. So my first interval here was 1.253 up to 2.170. And this last interval here goes from 2.802 up to 3, because they're only concerned about up to 3. So that's where the function would be concave up on those intervals. All right? So the explanation was what I wrote up here earlier, and then the answer was the 2 intervals that I put. Okay? Let's move on to part B. They want us to find where f has a relative min or max or neither. Okay? So for this one, let me give some explanation first, and then we'll go into answering it. For this one, we're going to be using the second derivative test. And for that one, basically, you need to find your critical values. Those are places where the derivative equals 0. And then you plug those critical values, which we'll call C, you plug those critical values into your second derivative. Now, if your second derivative is greater than 0, then it's concave up. If your second derivative is less than 0, then it's concave down. Since it's a critical value, it's at either the very bottom or the very top of that concave up or down curve, in which case it's either going to be a relative minimum or a relative maximum. And so that's the idea there. Now, I knew I had to use a second derivative test here because they give me the second derivative. They didn't give me the first derivative. Otherwise, I'd probably just use the first derivative test, right? Now, but they do tell me something about the first derivative. They tell me that f prime of 1 equals 0. So that means that 1 is a critical value. So I'm going to plug that critical value into the second derivative, and whether I end up with a positive or negative answer, that will tell me whether or not I have a min or a max. So first of all, let's go ahead and begin the writing. So we'll say since f prime of 1 equals 0, x equals 1 is a critical value. And since f double prime of 1 equals, and now let's figure out what that is really quick. So let's go back to our calculator and type this in. I'm going to go back to the home page here, and I'm going to bring up the second derivative function, and we're going to plug in 1. I get negative 0.541 there. Negative 0.541. That means that f has a relative max at x equals 1. So, since this is a critical value, we can do the second derivative test and plug that critical value into the second derivative. Since my second derivative comes out negative, that critical value is at the top of a concave down function, and therefore that makes it a relative max. So that would be our answer to part B. Part C, honestly, it had me a little bit stumped, and then I looked up how to do it, and I just realized, you know what, it's just not worth us doing it. It's actually just not that helpful. It's a very weird question to ask. So I'm going to go ahead and skip that one for now, so we'll say just don't worry about doing part C. Let's move on to part D. Does the graph of f have a point of inflection? Well, we know that f has a point of inflection when f double prime equals, actually I should say it, when f double prime changes signs. Okay? So f has a point of inflection anytime f double prime changes signs. All right, so for that I'm going to go back and I'm going to look at my graph again. Now here's 0, it's right about here in this spot. And as you guys can see, my second derivative does not go above the x-axis, it stays below. And so we can conclude that it does not change signs at that point. As a result, we would say no, 0 is not a point of inflection. So f double prime would have to be changing from positive to negative or negative to positive. In other words, it would have to actually cross the x-axis, and it did not. So that one is done. Let's go ahead and move on to our next one. All right, so for FRQ number 1, part B, we're not using a calculator. So for this one, they give me a graph of G up above. They tell us it's twice differentiable except at 0. So apparently, for some reason, either the first or second derivative does not exist at that point. They tell me that f is another function where f of 0 equals negative 1, and its derivative is this. And this is a non-calculator based question, so we'll see what kind of interesting things occur here. So number 1, part A. Find the coordinate of each critical point of f and classify it as a min, max, or neither and justify your answers. So part 1, we want to find the critical values. Part 2, we want to decide if they're min, maxes, or neither. And part 3, we need to make sure that we justify our answers. So show your work and explain why, in other words. All right, so let's begin. Critical values are places where the derivative equals 0. So here's the derivative. Now we would set both of these equal to 0 and solve. Now this one, unless you kind of have some strong pre-calculus memory, that's impossible. E to the x can never equal 0. The way that I remember it is I think of the graph of e to the x, it looks like this. It can never cross the x-axis, and so it can never have a y value equal to 0. And so this one here will simply not give us a critical value. But this one can. If we add 5/4 to the other side, and then take the square root, we get plus and minus square root of 5 over 2. Square root of 5 is just square root of 5, square root of 4 is 2, and we don't want to forget that you get pluses and minuses when you take square roots. So there's my critical values. Now we want to know, are those, so I've taken care of my first thing of finding the critical values. By the way, critical values can also happen where a function is undefined, but this is a polynomial and this is exponential, and both of those functions are continuous everywhere, so there are no places where the derivative would be undefined. So we've successfully answered the first part of our question to find the critical points. Now we want to decide if they are relative extrema or not, and for that we're going to do our number line test. All right, so we have 0 in the middle. We've got radical 5 over 2 here and negative radical 5 over 2 here. And we just want to know, are these relative mins or maxes? So now, maybe you don't know what this is. I don't know what the heck it is. I know that the square root of 4 is 2. And so, but this is the square root of 5. So it's going to be a little bit more than 2. So if you were to divide a number that's a little bit more than 2 by 2, you're going to get a little bit more than 1. So that means that negative 1 is somewhere behind it, and 1 is somewhere behind that one, and then negative 2 would probably be somewhere over here and here. So this is somewhere, these numbers are somewhere between 1 and 2 basically. So you just have to estimate, because since it's not a calculator-based question, we just don't know exactly what those will be, so we have to estimate them. All right? So I did it by just saying, well, if the square root of 4 is 2, then the square root of 5 must be a little bit more than that. Okay? All right, so anyway, so now we're ready to go ahead and find our first derivative's value on these intervals. So what we're going to do is we're going to plug the test points in to our first derivative, and we'll see what we get. Okay? So for the first one there, let's plug in negative 2. If I were to plug in negative 2, that's going to be 4 minus 5/4. Now, 5/4 is about 1.25. Now, I don't need to get the actual answer. I could just know, okay, well, that's going to be positive because 4 is bigger than 1.25. And this is also positive because no matter what you raise e to, you're always going to get a positive. The negative just makes it become 1 over e squared, but that's still a positive number. So basically I've got a positive times a positive, which is positive. So for my first interval here on this side, we end up with all positives. Okay? And you're just going to continue doing that for the rest of them. I'll do one more with you, and then I'll just fill in the others automatically. So if we plug in negative 1, oh, my bad, 5/4. So this is just 1 over e, but that's positive. This is 1 minus 5/4, which is like 1 minus 1.25. Now that's actually going to come out to be negative. So here I've got a negative times a positive, which is negative. So on this interval here, we do have a negative again. Now if you continue to do that by plugging in and checking, you're going to find that this interval also comes out to be negative, and this interval over here comes out to be positive. Now they're asking what's the relative max. Well, let's take a look at our slopes. So for the first interval, we're moving in an upward direction, and then it comes down, and then here it goes down some more, and here it comes back up. So we have a relative minimum here and a relative maximum here. Okay? And so we have found our critical values, and now we need to state which ones are relative maxes and mins. So we're going to say that f of, well actually we'll just say negative radical 5 over 2, that's this point, is a relative max, since f prime goes from positive to negative at that point. You're going to say the same thing for this other one over here, but for a minimum instead. Radical 5 over 2 is a relative min since f prime goes from negative to positive at that point. So I've identified them, I've given my reasons, so I've answered all three questions. We've found our critical points, we've explained whether they're maxes or mins, and we've given an explanation of why, and therefore that question is done. All right, let's go ahead and move on to part B. Find all the values of x at which the graph of f has a point of inflection, and give reasons for your answer. So f has a POI, a point of inflection. Now I'm just being lazy here, guys. On your actual test, don't write POI, write out point of inflection. But f has a point of inflection when f double prime changes signs. Now, we saw this on the last FRQ that we did, but there we were able to graph the second derivative and see where it's above and below the x-axis. Here, we're not allowed to use a calculator, so we actually have to do a little bit more work than that. So the first thing we're going to do is we're going to have to find our second derivative. So here's my first derivative. So how would I find the second derivative? Well, I have something times something, which means we're going to be doing the product rule. Okay? So if I call this A and this B, let's see how this works out. A prime B, AB prime. Here we go. So A prime is 2x, B is e to the x, A is that, and B prime is still e to the x. Now, let's clean that up a little bit. Okay, so we want to find out where does this thing change signs. So we need to set it equal to 0. And in order to solve this, it might be helpful to factor out the e to the x. All right, and then what we're going to want to do is set this each piece equal to 0 and solve. Now we've already said that this doesn't have an answer, so we'll skip that. So what we need to find now is where does the other one equal 0? Now I'm going to rearrange the numbers here a little bit so it looks more like a standard quadratic equation. And we need to solve that. Now at this point, thankfully this is an FRQ, so what we can do is we can, let me think here. Well, I think we're going to have to just go ahead and solve it. So I don't like having this fraction here, so I'm going to get rid of it. I'm going to multiply everything by 4. Oops. It's going to be 8x now. And if I multiply this by 4, all that's left is the 5. And if you multiply 0 by 4, it's still 0. Then we're going to factor this. You're going to set each piece equal to 0 and solve. Now, you could have used the quadratic formula too. I just prefer factoring. I had a sneaking suspicion that it would be factorable because this is a non-calculator question, and when you're doing a quadratic formula, if you don't have a calculator, your answers kind of come out to be so weird you can't really even estimate what they are very well. So here are the two places where the second derivative equals 0. Now let's go ahead and do a number line test, because remember, we're looking for the place where f double prime changes signs. So I found where it equals 0, so now I just want to see if it's where it's changing signs, if anywhere, using a number line test. All right. So let's plug in a number less than this. Now that's about 2.5 there, negative 2.5. So we'll plug in negative 3. We'll plug in 0. And we'll plug in 1. Now, we may have to estimate, because it just may come out to be kind of nasty. I don't know. I wish they would make the equations a little bit simpler if they're going to have things be by hand, because it's just kind of tedious. You can just make a simpler equation if you're going to do something by hand to get the same point, but whatever. We're not making the test, so we're going to have to endure it. Okay, so this is going to be negative 6 over e to the third, this first piece here. This is 9 minus 5/4. Now we need to get a common denominator here. We're going to do our best to see if we can estimate whether this is positive or negative without a calculator. So this will be 36 minus 5, which is 31 over 4. And then the e to the negative 3 will go in the bottom. All right, now we need a common denominator for this. So we'll multiply the top and the bottom by 4. All right, and then negative 24 could be combined with 31 to make 7. And that's a positive outcome there. There's no negatives. So we end up with a positive. All right. 0 might be easier to plug in. Let's try 0. So if I plug 0 in here, the whole thing just becomes 0. And if I plug 0 in here, we're left with negative 5/4 e to the x. And so as you can see, we're left with a negative 5/4. E to the 0 is just 1, so you can ignore that. So you're just left with a negative, so that's negative. And my guess is that the last one's going to be positive anyway, but let's see. Let's be certain. We'll plug it in. Oh, maybe not. All right, so this is 2 and this is e, so we just have 2e here. Here, if I get a common denominator, it's going to be negative 1e over 4. If I get a common denominator, 8e minus 1e is 7e over 4. So that's positive again. So there we have it. So we do have a point of inflection here and here because it goes from positive to negative and then it goes from negative to positive. So our final answer then for part B will be F has a point of inflection at x equals 1/2 and negative 5/4, I think is what they were, right? Since F double prime changes signs at those points. So unfortunately, because this is a non-calculator question and because they, for abusive reasons, decided to make the equations complicated, this question became a lot harder than it really needs to be. So I want you guys to understand what the simple point behind this is. Point of inflections happen when the second derivative changes signs. So to do that, you find the second derivative, and you do the number line test with that, and you see where it changes signs. It's just that unfortunately, because of the type of question they asked, it became harder because it was embedded in all kinds of complicated basic math. All right, let's go ahead and take a look at part C here. Fill in the missing entries in the table below to describe the behavior of G prime and G double prime on the interval. Indicate positive or negative and give reasons for your answers. All right, so they want to know, what do I know about G prime on the interval from -3 to 0? So here's -3 and here's 0 on the graph of G. What do I know about G prime? Well, G prime is the slope. So since G is increasing on -3 to 3, that means that G prime is positive. Okay? How about this one from 0 to 3? It's still increasing. So we could actually just add to our answer here and just put positive here also, because the function is increasing the whole time. All right? Now, G double prime is about concavity, right? So how would you guys describe the concavity of our function from -3 to 0? How would you describe that concavity? That looks like it's concave up. So since G is concave up on -3 to 0, that would mean that G double prime is greater than 0. In other words, it's positive. Now, how would you describe the concavity of G on this interval? Well, that looks concave down to me. So we would say that G is concave down on the interval from 0 to 3. Therefore, G double prime would have to be negative on that interval. And that's it. All right, one more. Let H be the function where it's the product of f and g. Is H increasing or decreasing at 0? And give a reason for your answer. So we know that H is increasing if H prime is greater than 0, or it's decreasing if H prime is less than 0. So basically, we need to find what H prime is, and that's going to require a product rule. So H prime is going to be equal to f prime times g plus f times g prime. Now we want to plug in 0. So we want to find out what is f prime of 0 and what is g of 0, what is f of 0 and g prime of 0. All right. So f, I think they might have told us that initial condition in the beginning, actually. Let's see here. They did. They told me right here that f of 0 equals -1. So let's go ahead and put that back for now. So we know that this is -1. What is g of 0? In other words, what's the y value on our graph at 0? Well, at 0, the y value seems to be 2. So that means that we could replace g of 0 with 2. F of 0. Oh, you know what? I put this -1 in the wrong spot, you guys. My bad. This was -1. This one we need to find still. I'll come back to that. But let's do g prime of 0. What is g prime of 0? It's, you know, this is kind of it's kind of shady, but it's right here. I don't know if it's also in the instructions at the top, but it's right here. G prime at 0 is 2. So That's unfortunate that that's hiding like that. It's just stuff where they're really trying to trick you, which is sad because it'd be nice if they would just try to measure what you guys know rather than make things so convoluted. But anyway, so yes, we could see that G prime is equal to 2 at that point. All right, so now we need to find F prime of 0. Now F prime of 0 can be found by plugging 0 into our function that they gave us at the beginning. Now e to the 0 is just 1, and that's just 0, so you're left with negative 5/4 there. All right, so let's go ahead and simplify this and find out what h prime is. So 2 times negative 5/4 is negative 5/2, and this is negative 2. And we could take the time to combine these if you wanted to, but it doesn't really matter. When you put two negatives together, you're going to get a negative. So therefore, h prime is less than 0, and h is decreasing. And there's our answer. So h is decreasing if h prime is less than 0. We found h prime, plugged in 0, and we found out that it's negative, so that means that h must be decreasing. All right, and that'll do it for that particular FRQ, and that'll also do it for our work for the day. So we'll see you guys tomorrow. Have a good one.